Hello, I'm going to be covering my project on evaporation enhancement via additively manufactured thermal isolators. So what do I mean by that? So thermal isolation is essentially where you take a fluid, of some kind, and you are placing a permeable barrier at some point within the fluid so that one portion of it can be heated up while the barrier resists some of that heat transfer while still allowing some of the rest of that fluid to wick up into the locally convected or locally evaporated fluid. So for something like a large scale desalination plant, a great deal of energy is used in just raising the temperature of the fluid as a whole. Well, if we're looking at using some kind of thermal isolation, then we can try to focus the majority of that in just that top layer. So if we're using, say, sunlight to try performing that evaporation, then it's going to be utilized much more effectively rather than pointlessly raising the entire fluid's temperature by a few degrees, only for it to cool off whenever it comes to nighttime. So for the testing, I developed a number of 3D printed geometries for potential barriers. And as a little bit of a side test on it, I wanted to try out angling the vertical channels within these pieces to see if there was any effect to be had from the water vapor that would be coming off of this. So testing setup, I mean, as you can see there, just under 4 inches diameter, with there being about 3/4 of an inch of fluid above the specimen. There's multiple thermocouples throughout the testing apparatus, though all told, the mass is of significantly greater importance here, with the source of energy being a 185 watt UV light that was shining over this thing for 2 hours, and to give it a full day of rest between some of these tests. So as far as the numbers go, here were some of my results. So as we can see on this, the baseline ends up being fairly linear throughout the testing, a fairly slow rate, only about 1 gram per hour, slightly above, say, 1.1 grams per hour. Whereas once we start getting any barrier at all, there is some effect to be had based on the angling, but just any barrier at all seems to have drastically increased the amount of evaporation that was ongoing. At even just the first hour, with channels being angled out, we've got as much, if not just a little bit more, evaporation going on than the baseline did over the course of 2 hours. So when we start taking a look at some of the rest of the geometry, angled out ended up performing the worst of the 3 barriers. The vertical being the middle ground, being second best, second worst, however you want to look at that one, and then angled in performed the best. Now the difference between these is ultimately quite low, but it does show that there is at least some manner of optimization that can be performed on these geometries to further increase the amount of evaporation that's going on. And if we're just looking at the overall evaporation at the end of the 2-hour mark, each of these are significantly above that baseline, where we have over 200% evaporation enhancement if we're looking at it on an hourly basis. Now, these were calculated based off of 30-minute the data points were taken at 30-minute intervals. So any kind of testing for evaporation enhancement has to take place from at least an hour and beyond. That said, if we also take a look at the enhancement based on the total amount of mass that was evaporated, we still end up with more than double the effect of the baseline. And in the instance of the angled in setup, it was nearly triple the effectiveness. So principal effect here is absolutely that any kind of thermal isolation on its own is more than sufficient to increase the rate of evaporation for pure water. That on its own can drastically increase the effectiveness there, though notably, the channel geometry where the channels were beginning to angle more and more inwards, focused toward the central point, there was a consistently increasing enhancement from that effect. And it does appear that optimizations can be performed on this. Further testing could just focus on, say, getting a video of the water vapor to help explain some of that channel behavior.